Hello everyone. So today we'll talk about the interaction between charges. Now the concept of interaction between charges is very important to help you to understand the discussion about electricity, which we are going to study thoroughly in the following weeks. Now if you look at this diagram, I believe most of you have performed this experiment during your secondary physics lab work, in which when you rub a plastic ruler with fabrics and after that place the ruler near to pieces of papers, you'll notice that the pieces of papers are being attracted towards the ruler. Now the mechanism behind this phenomenon is caused by a situation known as static electricity. We define static electricity as imbalance of charge. Now in this case here, when you rub the plastic ruler with fabrics, the plastic ruler loses its neutrality. Losing neutrality means it either gain positive charges or gain negative charges. Now in this scenario, most of the time the ruler will be gaining negative charges. So when you place the ruler, which is full of negative charges right now, near to the pieces of papers, the positive charges in the papers will interact with the negative charges of the ruler, causing the papers to be attracted. Now, to help you to understand the concept of static electricity or imbalance of charge, let's say we consider two metal rods. One is neutral and another is charged. So as you can see here, the charged metal rod is full of positive charges. So if I place the charged metal rod near to the neutral metal rod, which is this, the electrons originally in the neutral metal rods will interact with the positive charges of the charged metal rod, causing the electrons in the neutral metal rod to leave its location here, moving towards the charged metal rod. So in other words, the neutral metal rod right now is losing electron. So when it loses electron, it becomes more positive. So this is what we call losing neutrality. Now, if we have two negatively charged objects and placed near to each other, the objects will repel each other. Similarly, if the two objects are positively charged and placed near to each other, they will also repel each other. However, if the two objects are storing different types of charges, one being negative, one being positive, then these two objects will attract each other. The existence of repulsion or attraction between charged systems is due to the existence of electric force, or in Malay is what we call daya electric. So this electric force can be described using a law known as Coulomb's law. So mathematically, Coulomb's law can be written as this, where K is what we call the constant. Okay, so please memorize this value. Q1 represents the total charge of the first system, while Q2 is the total charge of the second system. Lastly, R represents the separation or the distance between the two charge systems. So this SI unit for charge is Coulomb, or you can just write a capital letter C. So if you look at this equation here, it is actually giving you the magnitude only. Okay, bermakna hanya nilai saja, tak ada arah. But you should understand that force is a vector quantity. So apart from the magnitude, direction is also very important. This picture is the same as the one that I showed you earlier on, in which two positively charged objects, when placed near to each other, they will repel. If both are negatively charged, they will also repel. If they are storing opposite type of charges, one positive, one negative, then they will attract. So please remember this scenario. As I mentioned, electric force is a vector quantity. So the formula that I showed you just now, which is only giving you the magnitude, is not sufficient. During calculations or problem solving, we have to use the vector form of Coulomb's law, which is given by this formula. So if you compare the two formulas, K remains unchanged, which is the proportionality factor, and I hope by now you have memorized the value. Q1, total charge of the first system. Q2, total charge of the second system. The only thing different here is the denominator. Instead of using R square, now I'm using R cube plus the direction, vector R. So vector R can be defined as x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Now what is this I cap, j cap and k cap? If you try to recall what you have been taught in PHR 110, I believe your lecturer has told you, I cap represents the positive x direction. J cap represents the positive y direction. And lastly, K cap represents the positive z direction. Now this x1, y1, z1 is actually the coordinate of the charge of interest. What is the meaning of charge of interest? Charge of interest means the charge that we are trying to calculate. If the question wants you to calculate the electric force acting on charge system A, then the location of charge system A will be x1, y1, z1. So after you have identified which charge system is the charge of interest, then you are going to write the coordinate as origin, which means 0, 0, 0. Are you clear? Now let us look at one example. In this picture, we have two charge systems. One, positive 2 microcoulomb. The second, negative 2 microcoulomb. And both charge systems are placed on a horizontal line, separated by a distance of 5 centimeters. So the question wants you to calculate the electric force acting on positive 2 microcoulomb. So step 1, we have to identify which of these two systems is the charge of interest. So remember what I told you? Charge of interest is the one that the question wants you to calculate. Now, obviously, the question wants us to calculate the force acting on positive 2 microcoulomb. So automatically, we are going to label the location or coordinate of positive 2 microcoulomb as the origin. Since we have determined the charge of interest, which is positive 2 microcoulomb, so we shall label the location or coordinate of positive 2 microcoulomb as the origin. Origin means x1, y1, both are 0. So based on this origin, we are going to label the coordinate of the neighboring or interacting charge system, which is negative 2 microcoulomb. So in the picture, you can see that the negative 2 microcoulomb system is located 5 centimeters to the right of positive 2 microcoulomb. So to the right means x2 is positive 0.05. Can anyone tell me why y1 and y2 both are 0? Yes, because both of them are located at the same level. So that's why y1 and y2 both are 0. What happened to z1 and z2? How come we do not have to include z1 and z2 in this case? Yes, because this question is only involving the xy plane, di atas sekeping kertas. Hanya SATA x, y. Tak ada paksi z. So there is no need for us to include z1 and z2. So from these two coordinates, now we will try to figure out what is the value of vector r. So we substitute x1, y1, x2, y2 into the vector r formula, x1 minus x2 I cap plus y1 minus y2 j cap. We obtain negative 0.05 I cap. Now, how come it is 0.05? Don't forget, in scientific calculations, all units must be expressed in SI unit. So we convert 5 centimeter into 5 meter. So the next step, after you have figured out what is vector r, we will use this value to determine r, which is the magnitude of vector r. So still remember how to calculate magnitude of a vector using this approach? Okay, so for those who have forgotten how to calculate magnitude of a vector, please take out your PHR 110 note and refer. Okay, so from here, we obtain the magnitude as 0.05. Lastly, we substitute the value for vector r, magnitude of r, into the vector form of electric force. K, the proportionality factor, Q1 given, Q2 given, vector r from here, r from here, solve the whole thing, we'll get 14.38 I cap. Now 14.38 here is the magnitude. So we can denote it as 14.38 Newton. But what is the meaning of I cap? As I've told you just now, I cap means positive x direction. So to the right or positive x. Now if you look at this diagram here, positive 2 microcoulomb is being attracted to negative 2 microcoulomb. Attracted means ditarik ke arah ini. Ditarik ke arah ini bermakna pergi ke kanan. Pergi ke kanan bermakna ke arah positive x. And that is the meaning of positive I cap. As for the application of electrostatic concept, it can normally be seen in modern gadgets such as photocopy machine or laser printer. Now, both photocopy machine and laser printer, they have a similar setup in which both of these gadgets have a roller or drum installed inside them. So when we want to, let's say, print out a letter A, what happens here is that the computer will ask the drum or roller to generate a letter A using positive charges. From this picture, a letter A has been formed on the drum or roller using positive charges. So as the roller turns, it will be exposed to toner powder. Toner powder are negatively charged particles. So what happens when you have negatively charged particles exposed to positive charged letter A? Yes, the negative particles, which is the toner powder, will be attracted to the positively charged letter A. So when the roller turns further, reaching the paper, the negatively charged toner powder will be printed on the paper. And this is how we obtain the letter A printed on the paper.